Okay, the title of this lesson is called Scale Drawings and Models. Scale Drawings and Models. Alright, let's just talk about the scale drawing at first. My last class, I talked way too much, so I'll try to get into the meat of the problem so I don't talk too much. But I will say this. Back in the day, when before GPS and before computers and internet and Google Maps and MapQuest and all that kind of stuff, we actually had a thing called a map. You ever see one?
What's a map?
It's paper. It's actually made of paper. Okay, looks kind of like Alex's, except it's supposed to be a real stuff instead of his imaginary, the city in his mind. Okay, who knows? That city might actually be a real city one day, and you'll say, "I remember when that kid was drawing all that stuff on the map, and now look, I live in that. I live in that city."
Sorry.
We'll call it Alexville or Tokarski Town. Okay,
Yeah!
how's that?
Town.
Tokarski Town. Okay. So anyway, before I am any more silly than that, let's just talk about a map. I just happen to have a map right there. Look at that. Pretty cool, huh? What I'm looking at here is, if I can, there we go. What I'm concerned about. Listen, let's not talk. Let's just listen to me. I guess these are all places where they might have like traffic cameras or something like that if you click on one of these. That's not really what I'm concerned about. I'm just looking at this map. This is us right there in Bear, and you've got all of humongous Delaware, okay? All, 90 miles of it or something like that? I think from top to bottom it's supposed to be like is it 100 miles? Okay. Where, yeah, I mean, you basically, you go to, in Texas, a guy on a ranch will go to his next door neighbor 100 miles away, but us will take from one end of the state all the way to the bottom is 100 miles. But what I'm looking at is this thing right here. Do you see this? It says 10 miles and 20 kilometers, and it kind of shows you this right here. A lot of maps will do this. They'll say something like 1 inch equals whatever. Let's say 10 miles. Okay, 1 inch equals 10 miles. That could be possibly 1 inch on here. But what it's saying is from here to here, if you go that length, that's 10 miles. So if you wanted to figure out how far it is to get from, let's say, Bear to, I don't know, let's go to Seaford, okay? Let's say we wanted to go to Seaford, all right? Don't know why you'd want to go to Seaford. I've been to Seaford. There's not much to see there, okay? But let's say let's go to the beach. Let's go to Rehoboth, okay? Or Lewis.
Rehomo.
I don't want to, shh, don't say that. We're live, okay?
Hey, we're recording.
All right, I know. That's my point. That's what I meant by we're live. Okay, so let's go to Lewis instead of Rehoboth, okay? So here we go. If we're going to go from Bear to Lewis, we're going to figure out approximately how many miles. This is not super accurate, is it? Because we're not going in one straight shot from here down to here. We're going along the road, okay, that kind of thing. But if we wanted to get a general idea of how many miles it was, we would take this, all right, this measurement. Now I can't write on top of this, so I don't really have any way to do this, but let's say that's every 10 miles. So what would you do? Let's just pretend it's an inch. You could take a ruler, couldn't you? And just say, now you probably wouldn't measure from here straight down because you're not really driving straight. You're coming around here. So maybe measure from here to here. That's 1 inch, 2 inches, 3 inches, 4 inches, 5 inches, 6 inches. Let's say 6 inches. That's probably more than that. I don't know, maybe 7 or 8 inches. All right, so I forget exactly how many miles it is there, but my guess would be around, I don't know, 70 miles, maybe, something like that. What's it take, like an hour and a half to get to Lewis from here? So anyway, but what you're going to do is, this doesn't represent, I mean, this 1 inch, of course, Delaware's, it's not very big, but it's a whole lot bigger than this map is, right? Would you agree? Yeah. So it's a scale factor. This is a scale model, okay, or a scale drawing of the state of Delaware. So it says every time you go 1 inch on this model, then that means you're going to go about 10 miles. Make sense? So you count out how many inches you have until you get to there, and that tells you how many miles you're going to go. Not the most accurate thing in the world. Today, now when I was in 9th or 10th grade or 8th grade or whatever, 8th grade, never even knew what geometry was. But anyway, when I was your age, GPS wasn't even a thought. It wasn't even something that you would say, You know, it would be really cool if some little computer thing would tell me how to get from point A to point B and tell me what turns to make. I mean, we couldn't even imagine anything like that. I mean, that wasn't even on, the most sci-fi movie. Okay, we would have never even considered anything like that. I mean, and now it's a reality, and we just, no big deal. I've actually had 2 GPSs, and I've had them both stolen out of my car. So now I have my phone. I got a Droid phone, and now it's got a GPS right on my phone. For goodness sakes, my goodness, this tells you how old I am, I guess. I mean, when I was your age, I would have never even dreamed about carrying around a phone in my pocket, walking around and talking to people. I mean, we still had cords on our phones. When I was, we actually had the push buttons, but when I was a kid growing up, we had the rotary dial. You ever see that?
I always wanted one of those.
We had it, where do you even know? Yeah, you turn it this way and goes. So I hated calling numbers with a bunch of 9s in it because you had to wait forever. Because you go around the 9 and it goes ding 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 ding, and then you hit an 8 and go ding 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 ding. I always loved a lot of 1s because it was quick. 1 1 2, that kind of thing. You guys probably don't even know what I'm talking about, do you? Do you? Okay. Wasn't there a commercial on? There was a TV show or a commercial where, I forget what it was. Did I see it yesterday? Where it was a rotary dial thing, and the guy says, "Okay, for more information, press 1." And all he had was a rotary phone, and he couldn't press 1. Oh, I know what it was. It was a commercial for that Raising Hope. You ever see that? It's on Fox. It's a sitcom. Anyway, he said, for more information, press 1. And he didn't even have a push-button phone. He just had a rotary phone. And so he dialed 1, and it didn't do anything. And so the dad's like next to it. He says, "Oh, I think I can do it." And here's a 1, beep. And he says, "You have dialed 5. If that's correct." And we're like, "Oh, man, we're so close, But anyway, that's how I remember phones. So that's just how old I am. Yeah, the OnStar
They
thing.
always mess up.
Do they really?
Yeah.
I've never tried it because my car's a piece of junk. And it's real old, and I don't even have power lock.
Oh my God,
I don't even have the button for the locks or anything. Oh yeah, that's what I grew up in. All right. Anyway, here, let's go back to this. So, for instance, let's say you're let's do this example right here. This is actually Nashville to Memphis. So we're out of Delaware now. We're in Tennessee. All right. So N is for Nashville, M is for Memphis. And if you look on this map, it's on page 512 if you want to follow along. Here's the scale factor. They don't just draw it for you. They tell you exactly 0.4 inches on this map. If I measure out 0.4 inches, that's going to be 40 miles. This is the scale. So 0.4 inches to 40 miles. That means every time you go 0.4 inches, which is a little less than half an inch, you're going to go 40 miles. All right, that's what this thing is telling you. And let's say on the map you took a ruler out and you measured on the map the distance from Nashville to Memphis on the map. And you measured it, let's see what they put, 1.5 inches. Okay, so you measured 1.5 inches. All right, that's your scale factor right there. And you actually measured 1.5 inches. We have to figure out approximately, this is approximately, okay, this is not real accurate at all. But this is approximately how far is it from Nashville to Memphis. So what do you think you would do? This is a scale factor, isn't it? So let's write it as a what?
Proportion.
Yeah, but let's give me another word. Instead of the colon, what would we write it as? A fraction, right. Let's write it as a fraction. It's a comparison. It's a ratio. And we will make a proportion. So you are right. We are going to have a proportion. So it's 0.4 inches to what? 40 miles. So every time we go 0.4 inches, that means we've gone another 40 miles. Does that make sense? Yes?
Yes.
Okay. I'm thinking of something else you could do. You could kind of reduce this down if you wanted to, but I'm not going to do that. Let's just stick with this, okay? And we measured 1.5 inches. So look what we're going to do. This is our scale factor right here. This is the actual measurements. The measurement that we measure on the map and the measurement of the actual miles it is from Nashville to Memphis. So, sounds like a song, doesn't it? From Nashville to Memphis? I don't know. I should write like a country song. All right, so what are we going to put up here? The inches, 0.4 inches to 40 miles is going to be what? 1.5 inches to what?
X.
To x, yeah. So we'll go x miles. It's a really simple concept. It's not that difficult. So 0.4 to 40 equals 1.5 to x. Now we just cross multiply. So it's 0.4x equals 1.5 times what? times 40. Just a little cross multiply it, right? Divide this by 0.4. What does it come out to be? 150, I think, isn't it? Yeah, because this is, what, 100? Watch. If I move this to the right one place, I move this to the right one place, that 4 goes into that once. Does that make sense? So it's 1.5 times 100. Move it once, move it twice, 150. Did that make sense, what I just did right there? Okay. So, I mean, you could throw it into a calculator. That'd be perfectly fine. But that was kind of nice to do. So, approximately how far is it from Nashville to Memphis? 150 miles. Okay. Now, of course, the two cities are pretty big, so it depends where you start, right? Do you start closer to Memphis, or do you start on the other side of Nashville? Where are you going in Memphis? It all depends, but that's an approximation of about how far it is to get from Nashville to Memphis. Okay, let's do one more. That was scale drawings. Let's talk about scale models. My dad wasn't really big into this, but we've had some toy trains. You ever see toy trains? You put around the Christmas tree, it goes chunk, chunk, chunk. You got the rails and that kind of stuff. Some people are really into it. I have an uncle that's really into it. He's got this room in his house. The whole entire room in his house is this model train set, and he's got, like, I don't know how many, 3 or 4 different trains are going around. He's got the little town. You ever see that?
Yeah.
Has anybody ever seen that? Yeah, it's kind of interesting. I don't know if I could spend all my time doing that, but he likes it. He enjoys it. He's a retired guy, and he spends time, making sure everything looks just right. He's got a place where he can go to the depot and it can, like dump the coal into the trucks or whatever they call those things, the trains and all that kind of stuff. And it's kind of cool looking. So that's a scale model. Now, those are trains. I mean, they actually are trains, and they're on tracks and all that kind of stuff. But are they the, quote, real size? No, they're not. They're scale models, aren't they? My dad, he doesn't do a lot of train stuff, but he does remote control airplanes or radio control airplanes. He does this a lot. And that's his big thing since he's retired. He's been doing it for a few years now. And he flies these airplanes around. It's actually kind of cool. He does all these loops, and he does these big old circles in the sky, and he lands. Even in the snow, he's got sleds, like these little ski things that he puts on the bottom of his plane. So when he comes in, it'll skid along the snow and that kind of stuff. Yeah, it's kind of cool. But my dad said, I said something about flying a real plane. He says, "You mean a full-scale plane?" And he never likes me to say a real plane because he figures his planes are real. They fly, They go up in the air. They do all kinds of tricks. He figures they're real planes. When I say a real plane, I'm talking about a full-scale plane, okay? That's what I'm talking about. But he takes a little... I'm sure he's not really offended, but, he says, "Oh, you mean a full-scale plane," because his are different scales. So that's what we're talking about this model stuff. So if you look on page 513, there's a little picture of this car, this old car. Now that's obviously not the size of an actual car, but it says the length is 6.5 inches. The length of this car is 6.5 inches. I'm not even going to try to draw the car. It's in the book for you on page 513. Now it says the actual length of the car was 13 feet. Okay, so this is the scale. Actually, let's do this. Let's say this is the length of the model. Okay, and then we'll call it the actual car. I hate to say that because some people would say, well, that's an actual model of a car, but you know what I mean. Okay, this is the real size of the car, and the length was 13 feet. Okay, it says what is the scale of the model? So we could do a little ratio. You could do it two ways. You could compare the model to the actual size, or the actual size to the model if you wanted to. I think they usually take the smaller one and compare it to the bigger one. So what would you do to find the scale factor of this thing? Good. 6.5, that would be inches, right? Over 13, and that would be feet. Always reduce. Okay, when you do ratios and fractions and things, always reduce. So that actually does reduce, doesn't it? 6.5. Somebody do that on a calculator. 6.5 and 13. It's 1/2, right? That goes once and that goes twice. So that means for every inch on the model, what do? You go how much? 2 feet on the actual, quote, the real car. Okay? So 1 inch to 2 feet. Does that make sense? Now, let's see. It says how many times as long as the actual car is the model? So how many times as long as the actual car is the model? Well, let's do this. It's not twice as big. So if this model is like if the width of the model is like, I don't know, 3 feet, it doesn't mean or 3 inches. It doesn't mean this is 6 inches, right? It's 1 inch to what? 2 feet, isn't it? Let's keep everything the same. Let's just get one scale out of it. Instead of 1 inch to 2 feet, we normally don't say that. We want to say for every inch, you're going to go so many feet, or so many inches, right? Okay, so this is 1 inch. Let's rewrite this in inches. What would that be? That'd be 24, but it's an inch, okay? I know it looks like 1, but I said it, all right? All right. Okay. Is that better? Okay. So that's 1 inch, and this is what? 24 inches. So look what happens to the inches. They cancel out. So what is my scale of the model car? It's 1 to 24. So that could mean 1 foot to 24 feet, right? If the model is 1 foot, guess how long the car is? It's 24 feet. You got it? Or if it's 1 inch, for every inch you go on the model, you go 24 inches, right, on the actual car, the real car itself. Does that make any sense? So that's what the scale model is. So that's the number. They hardly would ever do this. They don't usually say, for every 1 inch on this model, you're going to go 2 feet. They normally don't say that on a model if they talk about the scale of these models. They go 1 to 24, or whatever the case is. Okay, it could be bigger, could be smaller, just depends on the scale of the model. I see this, I don't know, I like to watch these shows where they build stuff, and sometimes they'll draw a model before they do the building. You ever see anything like that on TV? Well, they have, like, they'll make this tower, right, and it sits on a table, you know, and they say this is what it's going to look like, but this is a scale drawing, a scale model, and they'll say this is a 1 to whatever, you know, a 1 to 10 or a 1 to, I don't even know what numbers they would use on those, but they would say it's a 1 to something scale model. It's exactly what it means. For every 1 whatever, inch, feet, you know, you go on the model, you're going to go, in this case, 24 on the actual thing. Make any sense at all? Yeah. I don't think that's too hard. Let me give you some problems to do. So here we are. So we're going to go pages 514 to 516. And we're going to go 5 to 19. And it's section 7.7. Okay, so all that should be on your paper. Now remember, today's quiz we were supposed to take on Friday. All right, so I actually do have a quiz tomorrow planned. Yes. Remember, this was supposed to be Friday, so it's, you know, the one we did today was supposed to be Friday. So we got a quiz Tuesday, which is tomorrow, and it's 7.3 and 7.4. I'll stop. These quizzes are so simple. All right, so there you go. 7.3, 7.4 is quiz on Tuesday. And by the way, you should be checking yourself. You should be checking the lesson plans yourself. But I'm just kind of giving it to you. On Wednesday, we're going to review for a test. And on Thursday, which is February, what, 10th? That's February, not February. February 10th. That's, we're going to take a test on Chapter 7.
Oh, there goes my good
Oh.
grade in this class.
Nope, it's a good chance to solidify your good grade in this class. That's what that is, okay? So Thursday, wrote it a little sloppy, but February 10th, that's this Thursday, we're going to take a test on Chapter 7. Okay, that's it. There's your homework. Get that done for tomorrow.